Good day, this is Ramon Villamanca, and today I'm going to present to you the course project for ITE-7104, Data Communication and Networking. ITE-7104 is one of the prerequisites courses required for the graduate program of MS Computer Science in my university. Let me just fix my... Okay, now it's good. So, this is the first part of the course project, wherein we shall discuss a few topics from the ITE-7104 course module, namely the session, presentation, and application layers of the OSI model. The second part we're going to answer the problem sets included in the course project. So without further ado, let's get started. We begin by defining what the OSI model is. The Open System Interconnection, or OSI model, is a reference model designed by the International Organization of Standardization in 1984, allowing diverse communication systems to interact using standard protocols. In simple terms, the OSI provides a standard for different computer systems to communicate with each other. Viewed as a universal language for computer networking, the OSI model is based on the concept of breaking a communication system into 7 abstract layers, with each one stacked upon the last, performing a particular network functions. Think of the OSI model as a car composed of autonomous functions that combine to achieve the end goal of moving the vehicle forward. The battery powers the electronics, the alternator recharges the battery, the engine rotates the driver shaft, an axle transfers the driver shaft's rotation to the wheels, and so on. The OSI model layers carry out the independent functions and to communicate with the layer above and below. The OSI model is composed of 7 layers. Each layer of the OSI model has a specific function and responsibilities, working together to facilitate communication between the devices of a network. The layers are the physical layer, which is the lowest layer of the OSI model. It deals with the physical aspect of the network communication, such as transmission of raw data over physical media like cables and wireless connections. It defines the electrical, mechanical, and procedural characteristics of the physical interface between the devices. This layer focuses on the physical transmission of bits. Layer 2, the data link layer. The data link layer provides a reliable and error-free communication between 2 direct connected devices in the network. It is responsible for framing data into frames, detecting and correcting errors, and managing access to the physical medium. This layer ensures the integrity of the data transmission over the physical layer. Next, layer 3 is the network layer. The network layer is responsible for the logical addressing and routing of data packets between different networks. It determines the best path for data transmission, handles congestion and control, and provides logical addressing through IP protocol addresses or Internet protocol addresses. Routers operate at this layer to forward packets across the network. Layer 4 is the transport layer. The transport layer ensures the reliable and efficient end-to-end communication between hosts. It segments the data received from the upper layer into smaller units. manages flow control, and provides error recovery mechanism. This layer uses protocols like TCP, Transmission Control Protocol, and UDP, User Datagram Protocol, for reliable or connectionless communication, respectively. Next, layer 5, we have the session layer. The session layer establishes, manages, and terminates communication sessions between applications. It provides services for session establishment, between synchronization, and checkpointing. This layer ensures that data exchange between applications is organized and coordinated. Next is the presentation layer. The presentation layer is responsible for data presentation, encryption, and compression. It ensures that data from the application layer is properly formatted and presented to the receiving application. This layer handles tasks such as data encryption, decryption, and data compression. And the last layer, layer 7, is the application layer. The application layer is the topmost layer of the OSI model. It provides services directly to the user application. This layer includes protocols and applications tasks such as email, file transfer, web browsing, and remote access. It interacts directly with the user and enables communication between network services and application. In this presentation, we will be concerned only on the 3 layers, namely the application layer, the session layer, the presentation layer, and the session layer of the OSI model. We shall discuss the definitions, functions, and the various protocols involved in each of these layers. The application layer. The application layer is responsible for providing network services and interfaces to application. It enables communication between user and application and the underlying network. This layer interacts directly with the users and provides services such as email, file transfer, web browsing, and remote access. The main function of the application layer is to establish communication and data exchange between different application and user processes. It provides a means for application to access network services and transmit data across the network. This layer handles application-specific protocols and data formats, ensuring that data is properly formatted and presented to the receiving application. Several protocols operate at the application layer, including HTTP, Hypertext Transfer Protocol, used for transmitting web pages and other resources over the Internet. It enables communication between web browsers and web servers. FTP, File Transfer Protocol, used for transferring files between a client and a server over the network. It provides functions for uploading, downloading, and managing files. SMTP, Small or Simple Mail Transfer Protocol, used for transferring or sending and receiving email messages between mail servers. It handles transmission of email across network. DNS. DNS stands for Domain Name System, used for translating domain names to IP addresses. It enables the resolution of human-readable domain names to their corresponding IP addresses. SNMP, Simple Network Management Protocol, used for managing and monitoring network devices. It allows network administrators to collect information and manage network devices remotely. DHCP, Dynamic Host Configuration Protocol, used for dynamically assigning IP addresses and network configuration parameters to devices on a network. It simplifies the process of network configuration for devices. Now we go to the presentation layer. The presentation layer, layer 6 of the OSI, is responsible for formatting, encryption, and conversion of data to ensure that it is in a format that the application layer can understand. This layer focuses on syntax and semantics of the data being transmitted. The main function of the presentation layer is to provide common representation of data that can be understood by different systems. It handles tasks such as data compression, encryption, and decryption. The layer ensures that the data is properly formatted and prepared for transmission across the network. It also handles translation, converting data from one format to another if necessary. The presentation layer does not have specific protocols associated with it like the lower layers of the OSI model or the layer 7 application layer. However, there are some protocols and technologies that operate at this layer or have functions related to it. These include, but not limited to, XDR, External Data Representation. XDR is a standard for describing and encoding data in a platform-independent manner. It is used for translating data between or transferring data between different computer architectures. TLS, Transport Layer Security. TLS is a cryptographic protocol that provides secure and communication over the network. It operates at the presentation layer and the transport layer. TLS ensures the confidentiality and integrity of data transmitted between the application. SSL, Secure Socket Layer. SSL is the predecessor of TLS and provides similar functionality. It is used for securing communication between web browsers and web servers. And we have the MIME, Multipurpose Internet Mail Extension. MIME is a protocol that extends the format of an email message to support non-text attachments, multimedia content, and international character sets. It allows email clients to handle different types of data. Last, we have the layer 5, the session layer. The session layer is the fifth layer of the OSI model. It establishes, manages, and terminates communication sessions between devices. A session can be thought of as a logical connection between two application or processes running on different devices. The session layer performs the following function. Session establishment. It sets up the initializes a session between two communicating devices and application. Session maintenance. It keeps the session active and ensures that both ends of the session are synchronized. Session termination. It terminates the session once the communication is completed or when requested by one of the participating devices. Dialogue control. It manages the orderly exchange and data between applications by establishing dialogue and control mechanisms such as token passing or turn taking. Synchronization. It ensures that data is delivered on the correct order and that both the sender and the receiver are ready to transmit and receive data. Session recovery. Last, it provides mechanism for recovering from session failure or interruption, allowing for the resumption of interrupted sessions. Like the presentation layer, the session layer does not have specific protocols associated with it like the lower layers of the OSI model. However, there are some protocols and technologies that operate in this layer or have functions related to it. This includes RPC, Remote Procedure Call. RPC is a protocol that allows a program on one computer to execute code on a remote computer over the network. It operates at the session layer and provides a way for applications to communicate and exchange data. NetBIOS, or Network Basic Input-Output System. NetBIOS is a protocol suite used for communication between computers on a local area network, LAN. It provides session services for establishing and maintaining sessions between devices. PPTP, Point-to-Point Tunneling Protocol. Point-to-Point Tunneling Protocol is a protocol used for creating virtual private networks over the internet. It operates at the session layer and provides session establishment and management for secure communications. So now we go to the networking demo for part 1. For this demo, I was looking for a network service to present as an example that make use of the OSI layers 5, 6, and 7 that we have discussed in the previous slides. I was thinking of a web service, but I already did that on my other subject 7108. So instead, in this demonstration, we shall create a mail server. Particularly, we shall make an actual mail server. This means that we are not going to make use of Packet Tracer or any other simulation app. The reason for this is that I saw that the exercises that we did about mail server in Packet Tracer is overly simplified, and we would learn more if we can create an actual mail server as an exercise. However, the mail server we are going to make will be local only. The reason for this is creating an external email is more involved and could be expensive. We have to make sure that we have a static IP, check if all mail ports in our servers are open, ensuring both of these may require extra payment from the ISP. We would also need a static domain name and propagate the necessary DNS records to ensure that our email would be delivered properly by external relays. Okay? If we can do the above mentioned, then the next steps will be almost the same as creating a local mail server. Although the steps for creating local mail server will be not as simple, it would be quite similar to what we did before with Packet Tracer. So these are the steps. First, we may have to install a local DNS server and create an A record for our mail server IP. Next, we are going to add a mail service to our existing server. This setup depends upon the server operating system and may involve installing a special mail server app. Next, we're going to set up our mail server application. Then we are going to configure the mail server, much the same as we did in Packet Tracer. Finally, we are going to test our email service. We are going to try and send received emails from virtual and actual machine to see if our server works using webmail and web clients. As we can see, implementing a local mail service, although not so difficult, is also not as easy as we did in the module with Packet Tracer. In our module exercise, we only did steps 3 and 4 of the steps listed above. So let us begin our experiment. So we are going to start our exercise demo. So the first thing to do is to go to our server. This is our server. I'm using Unraid. And the first thing to do is to install a DNS server. So we will have a good email address. I don't have a DNS server because I don't need to. Okay, so we will install Pi-hole. So as you can see, I already installed it before, so I don't want to reinstall. I will install it as a new one. Okay, so we will put it in port in IP 192.168.1.33, so you don't have to, because for example 80 is already used in my web server. So if I put the same address as my server, which is at 1.6, I will have a conflict. So I will everything here is same, so I'm just going to apply it, then it will install it. It's just wait a while, takes a while to install. It's getting late, but I have to finish this project. It's expiring in November, and I don't want to so it finished. Let's go to Docker. So it's running, so let's see the web UI. Okay, login. Let's see if we have any local DNS. Nothing. So it's okay. Okay. So we are going to later. We're going to create it. Okay. Now we are going to install our mail server, and my mail server of choice is Oxygen. I know you will say Oxygen is for big business, but this is very good also for learning. So I don't want to reinstall, I install a new one. Okay, so this is the same, but I'm going to install it in 192.168.1.66 now. Okay, so everything is okay. So apply it. This should take longer than Pi-hole because this is a big program. It is used in many corporate level, those that don't use the Microsoft Exchange, those company that use Linux or Mac, they use Oxygen instead. Oxygen is also available in Windows, but for Windows Server, it already has a default one, which is Microsoft Exchange. It comes with the Windows Server 2019 installation. But now I'm using a different server, Unraid, which is basically Linux. So, okay. I don't know why it's taking a long time. If you want, I can pause the video. Oh no, it's almost complete. Okay. So, spooling it up. So, okay. Now we're complete. Done. So let's go back to Docker. You know, Unraid is very good because it Dockerizes your servers. So, where is it? Oxygen. Okay, first one. So let's go to the web UI. It won't accept it because this is an old password. I think it's change me. Change me is the default password. Don't update. Continue. No, it's not change me. So let's go back to Docker and let's edit it. Show more settings. What is the default? Show more settings. What is the default password? Admin. Continue. It's asking me for a new password. Okay. I thought there's a default. Okay, I'm just going to repeat that. Continue. Okay, now I do have a license, but every time you tell this, you will have to say that this is new. But anyway, if you click it, it will detect that you have a license before. Then it will get that license. Okay. So I have to put my name, Ramon. Okay, my email. Okay, my company name, company. My address is address. My city is city. My zip code is 1900, whatever. And I live in Italy. Okay. Get pre-license. Okay. So it sends it again in my email. But don't worry. Continue. Okay. Now these are the default settings. The command line interface is at port 7000. SMTP is 25465 IMAP. Okay. It doesn't have POP3, but it does have webmail. So that's good. Okay. So continue. Okay. We will put a primary domain. We will put, now we will have to do this, okay? We will have to do the domain name server. What's our domain name server? Pi-hole, is it? Where's Pi-hole? Okay. I'm going to use the UI again. Then I'm going to add a DNS record. This is a record. No, we will use an A record. An A record is a DNS name using IP version 4. If it is IP version 6, it is called AAA DNS record. So we have, we will say mail, localmail.com, okay? Localmail.com is our, then we will put it the same address where we install our mail server. Okay, so this is the DNS record added. So let's go back to Oxygen, and we will put localmail.com. Okay, we just, the postmasters has to be there. Okay, okay, so finished. Okay, now, so SMTP sending and receiving is there. POP3 is problematic, so we don't use that. IMAP is there, webmail is there, and web admin is this port 9000. Okay, so SMTP is at port 25, and with SSL it's in port 65. IMAP is in 143 and 993. POP3 is nothing. Webmail, of course, it's 80 and 443. And web admin, as I told you, it's in 9000. Okay, so there's nothing. Manage domains, we only have one domain. Manage accounts, okay, we will add an account. We will add, okay, local, oh, sorry, wait, localmail.com, and my birth name is Ramon, okay, Ramon Villamanca, and the account name is Ramon, okay, at localmail.com. Password, I'll give it, okay, quick add. Then, don't save. Then we will add another account, same. Then we will put here user and slash user 1, and his last name is user, and his first name is 1, okay. And his account name is user1. I did it this before, so we just, okay, then click add, don't save, and then add another account, use 2, okay. I cannot spell 2, and user, and the account name is the account name is user2. Sorry, I'm an old guy. I have so speech lapses. Okay. Okay. Save. So now we have 4 users. Postmaster cannot be used, so only these 3 users. Okay. So now we're going to log out, and we're going to go to Docker again. And on Oxygen, we're going to go to, let's try let's try to edit. Let's see where, I think this is the one we should put for localmail.com. localmail.com 80 what's that? 8443. Port 80. No, it's not that website. Let's see what happens. I think we have to set our DNS on Mac. Let's try, huh? Let's see, why is it? Let's clear the screen, clear. NS lookup. Can't find it. And what? Okay. We are using VPN. So I'm going to disconnect with my VPN. Let's try it again. Still cannot find it. Okay. Now we really have to point to set our DNS to 192.168.1.33, our file hole. So okay, let's see. Now it finds it. Localmail.com. Okay, let's reverse lookup. Localmail.com. Now it finds it. 66. So let's try it here. Localmail.com. Why? There, okay. So let's try another browser. Let's going to try Chrome, okay? Localmail.com. Still bad gateway. Let's try Opera. Opera should do it. Localmail.com. Still bad. I don't know why it's bad. Anyway, let's 192.168.1.66, is it? 80. What is it using? Let's go back to Oxygen. Oxygen, where are you? Dashboard. Okay, review I. Okay, it says the webmail, because we're going to try it. Webmail, it says it listens to port 80. So why is it not listening to port 80? Bad. gateway. Okay. What happened? Let's examine what's happening. It says here, I'm up. Webmail. Is it port 80? It's port 80. 192.168.1.66 port 443. 443. And gateway. I know. Okay. Okay. We have to serve it. Let's go to my web server. Okay. And let's serve it. Host. Add host. Local mail.com. Local mail.williamanka.ddns.net. Okay. And let's point it to 192.168.1.66 port 80. Let's try this one. So we're local. Where is it? Okay. Web gateway. Let me post the video and find out where. So the problem is it's because it's not using SSL. It doesn't work in all browser, but it works in Edge, Microsoft Edge. So let's try it. 192. Oops, sorry. Now my keyboard is not working. Okay. 192.168.1.66 1.666. So now it's okay. So let's go to user 1 with password. Login. Now, okay. Now it has its initial message from the postmaster. What we will do is to send a new email to user 2. Okay, and let's say try this email. We will be using webmail first. Then we will try with an email client. This is a trial email. Okay. So send it. Okay. So it went to the send message. It should went to user 2. So let's try if we can use this one. Okay, let's try to use HTTP or 192.168.1.66. Still bad gateway. So only we can use only oxygen. We can only use this edge. So what to do? I'm going to log out. Okay. I'm going to log out. Let's see what I can do. Okay. 192.168.1.66. Still the user one. What I can do is I'm going to exit Microsoft Edge and then do it again. 192.168.1.66. Okay, so now we can use user 2 and with a good password login. We should have the message from user 1. So we see that we have the message from user 1. Okay, so now we're going to set it up with the mail app of default mail app by okay. Now let's remove this, erase, delete. We already have we will add one mailbox. Okay, mail settings, accounts. Okay, so accounts. We have how many accounts we have? Okay, we add an account. Sorry, you cannot see it. I'll bring it up. Okay. Okay. I'll bring this down. This is the mail server, the mail client for Mac, and we will add an account. Add account. Add other account. Email account. Okay, the address is Ramon at localmail.com. Okay, and I have the password. Okay, sign it. It's IMAP. Okay. The IMAP is localmail.com. Localmail.com. Okay, sign in. Show certificate. Continue. We have to do this. Update settings. Continue. I don't know why we have to do this twice. Update settings. Okay, done. Okay, now if we look here, where is it? Local mail. Okay, So now, this local mail, from this local mail, I'm going to create an email. If I know how to use this, okay, for a mail, file, new message, okay, from this to user 2, okay, user 2 at localmail.com, okay. So user 2, I'm going to say, hey user 2, this is trial, please answer. Okay, let's say that. Let's send it. Oh, okay. Yay, hey, hey. Okay. Let's send it. Should have been in the sent. Okay. Sent. Okay. No. Where does it go? Okay. So it says it has been sent. So let's go to user, go back to, okay, go back to Edge, and let's go back to 192. Let's try if he can localmail.com. Okay, advance, continue. See, now our DNS is working. I don't know this. User 2, I sent to user 2, right? So see, I receive it. Okay, so what's the point of using this? If this is only for within the LAN. Well, as we did before, let's go back to. So it's now working on local. Let's try to, if it will work. It will work outside our organization. Okay, so I have made this local mail. Okay, it's a bad gateway here, but I don't know if it works in Edge. Okay, let's try Edge again. What's the address? Local mail dot villamanca.ttns.net. It doesn't work because you have to make it as you have to force it to use SSL. So we're going to request a new certificate and we're going to force. Okay, save. Oh, I have to agree. Okay, save. Takes very long time. This is the problem with the SSL, but now it's completely OSL. So let's try it. Should be okay, but why not? Okay. Okay. Should be okay, but it is not. Okay, let's try this again. Edit our local mail villamanca.ttns.net. That's okay. SSL, let us not force. Save. Okay. Should be okay now. Still bad gateway. What's wrong? It's 66 and it's port 80. Correct. Custom location, we don't need that. SSL. Anyway, it works in the local. That is what our purpose is. I hope we work now here. Local mail dot williamanpa dot ddns dot net. That's right. Still bad gateway. Anyway, it works in the local. That's what our purpose is. So thank you, and this is the end of our exercise. We have created a web server, an actual web server that works on the local network. I've tried this before. It works outside, but don't know what the problem is. So this is the local version of the mail. Maybe it's the name, you know. I will investigate this, and hopefully, if I can tell you, I can still add it here. But anyway, that is creation of a mail server that works on the LAN. Thank you very much, and see you on the next part, which is part 2 of this demo. Thank you. Okay, networking demo. It turns out that our demo is not yet done. Upon reviewing the course project instruction, I noticed that we really have to do a packet tracer exercise after all. I really think that we would learn more with actual examples rather than simulations, but we ought to follow the instructions. Here are the summary of the steps we shall do for this demo. We begin with the topology that we already made. I based my topology to be the network we made in exercise 6. I chose it because it already have some devices and setups that we can test later. Then we will replace the DHCP server in exercise 6 with just a DHCP router. We will do this because a router is sufficient for our purpose. We do not need to have a dedicated server. Also, we need a router to create a new network. Then we will recycle our old DHCP servers and repurpose it into a file server. This is a normal practice in computer network servers. Older servers are repurposed into file servers. This is because file servers do not need much computing power, so any unit can serve the purpose. Then we will create a new network that includes the file server we created. And then we will set up a new telephony service on the new network we created. Telephony service is what we also called VoIP or Voice over IP service. Finally, we will test the resulting topology. We will simulate our network to see what is happening in the OSI levels. The existing web and mail server from exercise 6 would represent layer 7 and 6, while the new file server and telephony service would represent layers 7 and 5. Note that we do not have any specific service that ends in 5 and 6 only. It will always go to the layer 7 when it touch 5 and 6. This is the reason why in the TCP/IP model, TCP/IP group layers 5, 6, and 7 of OSI in the same layer only. So, let us begin our packet tracer experiment. Now we will open our exercise number 6. We will start it at that. Why is it not opening? I'm trying to open please. Okay, it's opening. I don't know where it is opening on my other. Let's wait a while for packet tracer to open. Now it opens. Okay. So now let's go. Oops, I don't have a paste. The instructor will be angry. So let's put myself here as a proof that I'm doing it myself. So this is our setup. Okay. Now, okay. So the first thing to do, I cannot do it, I have to do it here. Okay, now we're going to set up a new router as a DHCP instead of the old one. Okay. So let's pull out our DHCP. This is it. We just have to be careful because sometimes we make mistakes. Okay. So first thing is to get all the settings here. So we have its IP is 10, 17, 16, 0, 10. Its subnet mask is 255.255.0.0, and its gateway is 17.16.0.1, and the DNS is 11, and also in the services, the HCP. Okay, the name of the server is server pool. So we need all those information. Okay, now we will disconnect this. Sorry. Okay, I wonder why the mouse is not changing. I don't know. It's delete. Okay, so now we have to power cycle all devices because all devices have IPs. They need only the DHCP ones, you see? All have IPs. Okay, so we have to power cycle all so that they will delete their delete all their IP, so they don't have a trace of the IP. So now we need to put a new router, and I will choose 2811. Okay, so let's put it there. And then I will connect it. Do this, okay. And I will set it up. So in the config, where is it connected? Let's see first. It's connected to FA00. Okay. So let's do that. Let's have it in this one. And let's have an IP of 172.16.0, that not that 10 but that 1, because we want it also to be the default gateway. Okay, so let's go to CLI. It's very small. I hope you can see it. So still very small. Where is this? Okay, it's very small. Okay, how can I make it larger? Can it do anything? That one is only for this one. So I just hope you can see it. In Windows, it's not like this. Okay, I myself cannot see it. Okay, so I will put no shutdown. Okay, and now I have to exit. Okay, then we will create a pool. IP, what is this? IP DHCP pool server full. Okay, it worked. Then the network is 172.16.0.0 with the subnet mask of 255.255.0.0. Okay, so that's it. Now the default gateway, here it is called default router, is the router itself, 17.16.0.1. okay, is it okay? It's very small. Okay, now we also have to put the DNS server to 172.16.0.11. okay, enter. Now let us see if it is working. Not yet. Okay, let's see if it is able to give. While we are doing that, let's repurpose this. Okay, we will first get a switch. Let's have a switch, okay, and connect it to this server. Okay, we have the server now. Okay, let's see if it does work. Now it's working. You see, it gives already the IP of 03 here, and here it is 02. Okay, all others are static, so it has IP anyway. But now our router is serving as a DHCP server. Okay, now we are here. Okay, so now we will change the host name. Okay, we will change the host name to okay, to file server with ftp dot es.edu. Okay, doesn't do anything, but now, okay, we should turn off DHCP. Turn it off, okay, and then make sure that FTP is working. Okay, so now this is an FTP server. Okay, now for the config again, let's change the static address to 192.168.10.100, and the DNS is same. Okay, and for the, let's go here. Okay, this one is, sorry, it did not change. 192.168.10, what did we change? That 10.100. Okay, now this should be 2550. Okay, this is wrong. 10.1. Okay, and everything is correct. Okay, so now everything is working. Config, change. Okay, so we now connected it to the switch. Okay, and we will now connect the switch to the router, if I know how to do it. Okay, now it's connected. Okay, now let's wait for it to be recognized. And while we're in it, let's add this to our DNS server. To the DNS server. Where's DNS? Okay, let's add that. Let's add a DNS server with the name of ftp.es dot. Why is it not? Should be green by now. Okay, let's see. Edit. And then the address is 192.168.10.100. Okay, so let's add it. Why is it not green? Okay. Okay. This problem very small. Okay, config. Let's config this to let's config this to 192.168.10.1. Okay, and let's go to CLI let's say, put no shutdown. Okay. Okay. Okay, now it's working. Okay, so it should be working by now. Okay, now we will go again. Okay, we will go again and configure now it's working. Okay, we will go again and configure this one to be a DHCP server on the other side of the network. Okay, so first let's connect some IP phones. Okay, to our let's connect two IP phone. Okay, because this will be a help desk network. You can call it for help, or you can go to the FTP server to pull resources, to pull files that is needed for the help desk. Okay, so let's connect these phones to here and connect it to here. So we have two phones there. Okay, so let's set up this one to be the router for this side of the let's add one PC then, so that the help desk will have a PC. Okay, let's call this PC, what's that? PC4 help desk. Okay. Okay. So okay. And let's connect it also to the router. Okay, so we have two phones, a server in the help desk, and a help desk PC. Okay, and then we will set this up to be a router on the other side. Okay, now we are in interface 01. Okay, we already set the address, but we didn't set the gateway. Okay, so let's go to the config 1 IP version 4 10.1. Okay, okay, so we will go to CLI to set up. Okay, to set it up. So no shutdown, we already given that. Now IP DHCP pool help desk. Okay, help desk pool. Okay, help desk pool. Sorry if you cannot see it, I cannot see it myself. So now it's set up, and the network will be 192.168.10.0. Okay, and subnet mask is 255.255.255.0. Okay, the default router is router. We need this command so that the the computer on the help desk side can for the DNS server, it will not change, okay? 172.16.0.11. So the DNS is on the other side of this one, okay? Okay, and lastly, because this has a telephony service, we have to give this command. I don't want to explain it anymore because I don't know what it is actually. Okay, this is just I got from Cisco that if you want to set up telephony, you have to give this command. Okay, now it's okay. So let's go back to here and let's see if all okay, everything is okay. Then we have to set this up because there's no IP address here. We have to set this up to what is it? To DHCP, okay? Desktop. Okay, DHCP. Now it has an address. Okay, now this one is not getting any address because we have to set up also the first we have to turn this on because you see it's not turned on, so we have to connect it to the power. Okay, and this one we have to connect it to power as well. Okay, so it should be by some luck we will be able to. Okay, now we will have to set up telephony on the. Is it getting any address? No, because this one is not set up properly. Okay, so I had to set up the router again to accept telephony. Okay, CLI. What am I doing? Okay. Okay, is it getting any IP address? Not yet, but it's still, I think it's connected, so no problem. Okay. So, we have to set up the router so that it accepts telephony. Exit. If I can spell exit. Now, we have to put telephony service. Dash service. Don't forget the dash. Okay, now we have telephony. So we have max TN. Okay. This is the number of directory service that it can have. Maximum is 5, let's say. And then max e-phones, this is the number of maximum phones that it can have. Let's set it to 5. And then IP source address, our trunk line. Our trunk is of course the same as our router, and it will be using port 2000. Okay, where is it? Oh, wrong spelling. Okay, let's go there and change the spelling. It's so very small, I cannot see even. Okay, now it's okay. So we have to auto assign the numbers. Auto assign 4 to 6. and auto assign 1 to 5. Okay, by now it should be getting IP, still not coming. Okay, okay, now we have to set up on the switch also. Okay, so let's go to the switch, and on its CLI I have to enable, and I have to enter config. What is that? What's the command? Configure terminal. Okay, now it's here. So interface range, let's see where it is connected. It connected to FA02. Okay. So interface range FA0-2-5. Okay. FA02-5. Okay. Okay. Then we are in if range. Okay. Switch port mode access. Then switch port voice, and we have to have VLAN here, 1. Okay. Okay, let's see if it is. Why is it not accepting? Let's exit here, and let's see what else we didn't put. We didn't put.
Came back as terrorists and provided from us with info on how to attack those communities, how to bypass them, how to kill everybody in there.
Sorry for that. My TV began to okay, now it's getting an IP, so it's okay. So we now set up, so everything is looking good. This one has an IP, this one has an IP, this one has an IP, this one has an IP. Why is it not getting an IP anyway? Okay. Okay. Should be getting an IP by then. Okay. Now okay, both are up. Should be getting an IP. Okay, now it's at an IP. Now we have to go to the router again. Okay, in the router we have to set the number of the phones. ePhone 1. Okay, ePhone DN1. Okay, we have to set the number to whatever number we have. 1. I put 54001. Okay, and then I have to I have to exit, and then same command again, but now we have into, okay, and we have the number 54002, okay. You can put any number you want, just this is just an example, okay. Now it should be getting numbers, by now. You see, now this one is 54002 and this one is 54001. So now this is okay. So now it's we are going to test the system, okay. Let's see if this PC0 will be able to get a file from the other network, the file server on the other network. So let's have command. Oh, it's very small. Okay. View. Can I zoom in? No, it's zooming in but it's not zooming in. I don't know how to do it. Okay, if you know, just do it yourself in your own exercise. Okay, so let's have FTP, and our FTP server is ftp.amaes.edu. Should be amaes.edu. Could not open, okay. Trying to connect, could not open, okay. Let's see why. They're all connected. This is a router, should be able to route it. And this DNS server is 100, okay. ftp.amaes.edu 100, okay. Let's just pause the video and I will return to you with a solution. Okay, I'm hungry already, so I will just pause the video. So it just turns out that I made a wrong spelling. I put amaes instead of amaes. So let's make it correct. This is what I put before, amaes instead of amaes. So this one will connect. Now we have, what is our user here? On our services FTP, we have one user with Cisco. Okay, so let's go there. Cisco. You can zoom it out if you like. Cisco. Okay, now you're logged in, so we can make the command. Where are we? /FTP. So we are in the FTP, and then we can ls the system. Dir. Okay, it's dir. We are in Windows. So these are the files that we can get. It's also written here in the configuration of this FTP. So let's try if we can get that file. The command is get. The file is ASA842K8. These are some of the files that we can download. That bin. So it's transferring. How big is this? Okay. How big is it? Why is it taking a long time to transfer? So while we're waiting for that, let's have another service. It's done, I think. Let's see. Yes, it's done. Okay. So it's very big actually. It's 5.6 MB. Too big for our purpose. But anyway, so now we can exit. Is it? Exit from the FTP. No, quit. Yeah, okay. Now we're back. Okay. So FTP works. Now, let's see if this guy, okay, let's go to our email server and let's add another user. Email user 4, and the password is 1234, okay? Plus, okay? Now, this user is what? And where's email? Okay, he is user 2. Okay, so let's see if this user on another one, it's in the internet outside, if he can send an email to oops, let's exit this. Okay, let's go to email user 4 at mail, what's it, mail dot es.edu, mail dot es.edu and mail dot es.edu. Okay, okay, username user 4 and the password is 1234. Save. Now let's compose an email and let's save it to user 2 at mail.es.edu. Email message. Please email me. Okay. And send it. Okay. So cannot find the outgoing email server. Verify the outgoing email server. Okay, let's see what is the setting here. Mail.mes.edu. Okay, is it in the DNS? mail.mes.edu is 40. Your address is 40. Is your address 40? Is it correct? This is correct. Why is it cannot find? Let's see our setting here. User 3. Okay. Mail.mes.edu. Okay. So let's see the setting here. Mail.mes.edu. Okay. It's DEU. Okay. Save. So now let's compose again. Send it. I hope it's send success. Okay. Let's see if he receives it. Where is user 2? This is not user 2. Oh, it's user 3. Where is user 2? I think this one. Okay. Desktop. Where are you? This is user 2. To whom do I submit? I submit to I submit to user 2, but he did not receive it. So it's submit. Is this user 2? This is user 2. Ah, there, okay, I have to put, why is it like this? Okay, anyway, okay. So now, so I'm going to reply, hey, it worked. I'm going to send it. Is it sending? Let's see. Okay, now it's resolved. So let's go here again and receive. Now it's okay. So we have configured an external email. This is called an external email. Okay. So it's not within this network. Now, what else? Okay. How about we go to simulation and reset. Okay, now we will simulate this this PC asking for a web page here. Okay, so let's simulate getting a web page from www.almaes.edu. Okay, go. It will not do anything because this is simulation. Okay, we will just have to do it like this. Okay. It goes there. It goes to the DNS server. Let's make this larger. Then the DNS server finds it, sends a response back to the sender. Okay. Now the sender will again send the package and send it directly. Okay, this is the real message now. Now it's a success. Now it's going to give an ARP message that I receive it. This is not how slow it is, huh? Okay. Now, okay. Now it's now really getting it. Okay. So it's a success. Now you see it becomes HTTP now because he received the HTTP. Okay. Now he will acknowledge it again. Okay. Okay, so let's our real purpose is to trace the HTTP. So let's stop the simulation and let's see how the TCP HTTP work. Okay, let's now you see it's not this one, the one that this one. Now you see it works in layer 7. Layer 5 and 6 is not shown because I don't know why. It's supposed to have a layer 5 and 6 because it's asking for a session, but it did not. But because I don't know, maybe this is actually TCP/IP model, or I don't know how this Cisco packet works. Should have a layer 6 and 5, but it doesn't have. You only have the lower layers and HTTP. Okay, so now let's go back to real time. Okay, and let's see if these two will call. Okay, so let's have this, open it, and in the GUI its number is 50. Oh god. Okay, let's see it. Its number is 54001 and we want to call 54002. So let's go. Let's call 54. Am I doing anything? 5. Okay. 5 4 0 0 0 0 2. Okay, yeah, let's call this number. You see it's ringing, so let's do this one. See, and let's pick it up. Okay, so this telephony is working. Okay, let's see how it is. It should be session. But let's simulate it. Let's go there. Sorry. Let's go here and let's simulate the call. Okay. 54001. Let's call him. Okay. And let's call this and let's pick it up. Okay, so simulate. No, this is wrong. It's this is wrong. Go to the simulation mode again. This is what number? This is 5001. Okay, let's call only 54002, and let's not pick it up on the other side because this is simulation. Okay, let's see, goes to the router. Okay, well then the router says, okay, it's supposed to go to IP phone 0. So the switch Okay, now when I pick it up, now I pick it up. Okay, let's stop this. Okay, so okay, now, okay, let's okay. Don't mind those rings. Okay, okay. Oh God. Okay, just don't mind those rings because I don't want to. Should stop them. Okay, let's get this. What is it? Okay, now it's saying layer 7 again. Layer 7 again. So it doesn't see the session set, but it is there, believe me. So by this time we stop the our presentation and let's return to our no, we stop the simulation and let's return to the presentation. Thanks very much. We're now ending our program. Okay. No, I've done this before. So, thanks. Course project solution. So we now come to part 2 wherein we are going to solve the problem included in the course project. The problem is for us to complete the table related to subnetting as follows. Now, so that we don't need to repeat ourselves in calculating, I have prepared a small JavaScript program to do the required calculation. The snippet of the main function to calculate are as follows. So this we now start completing the table. So this is the third time I'm filming this part. I hope we got it right. It's always messing up because my recorder app keeps on capturing my other screen instead of this screen. So now we're going to answer the questions here, and this is our program, the JavaScript that I just showed you, but this one is inside an HTML. So let's answer it. First, let's try the first one, this one, with this one. Okay, let's try if this will be the same as this. You know why I put it here just like that is that let's clear it. It's because I cannot copy here. Why did they put it as a picture? This is only a table. No need to put it on a picture. Anyway, okay, let's calculate this one, and I think it's alright. Okay, so now let's go to the actual question. Second one is, let's clear it first. Second one is one, obviously I've done this before because If you want, I can remove. Can I remove? There's no option to remove the cookies. So I just put it here, and the given is this 225, 224. Okay, let's calculate. So it says here that this is 27, and the broadcast address is this one. Let's just copy it there, and then next one is 10.10.78.128. So let's clear it up. 10.10.78.128. This is the one. And the given is the prefix like of 25. So let's calculate. So it's asking for the subnet mask. So this is the subnet mask. And then it is asking for the gateway address. So this is the one. Next one is this one 192.84. So let's clear it up. Clear. This is captured by the cookie, so it's good also, so I don't have to write anything. And what is given is the subnet mask again, 192. Okay, so calculate. So it says this is 26. And what else does it ask? Where are we here now? We're still in number 5. Number 5 is 192.84. This one. Okay. And what is given is 24. Calculate. So it's asking for the binary. So let's give him the binary. And what else? Asking for the broadcast address. Okay. Broadcast address is just the last last address that is possible. So 7, let's clear. 7 is 179, 99, okay, this one. And what is given is 192, okay? Calculate. So this one says 26, and what else? Broadcast address, okay? Finally, Finally, it's 205. Let's clear this up. Clear. 205. 36, 72, 56. With this as 29. Let's calculate. This is okay, but that's not the one he's asking. He's asking for the binary. And what else? The broadcast address. Okay. So that's it. Okay. So I hope I have captured everything, and I will change my video using this one. Thank you. By the way, I will include this program on my submission, and hopefully I will also post it on my website so you can use it, or whoever wants to use it. This program only works if there is no borrowed bits from the host portion, but it's worthwhile to try. So let's go to the next, where I will just thank you. Okay, I will just we come to the end of our presentation and the end of our project video for ITE-7104. Thank you very much for your time, and sorry that it took so much time, your time. Really, I'm sorry. I want to demonstrate everything And thanks very much for my professor for giving me a chance to prove that I can do this. And as always, thank you and see you again next time if there is a next time.